So this is the equilibrium condition or least cost combination of inputs when there are two inputs are there. Okay. Now we can generalize the results for more than two cases also. Here we have only two inputs. One is labor and capital. For example, if there are three inputs or four inputs or more than two, we can generalize the results for more than two cases also with this simple equation. For example, if there are three inputs, say A, B, C, and say n number of inputs are there. By extending this generalization, you can say that marginal productivity of A by price of A is equal to marginal productivity of B by price of B is equal to marginal productivity of C by price of C is equal to like this up to marginal productivity of N by price of N. This is equilibrium condition for more than two cases. You can also, the same expression you can also write like price of A by MPA is equal to price of B by MPB is equal to price of C by MPC is equal to, for example, price of N by MPN is equal to marginal cost. In the production with one variable input, we have seen that price of input by marginal productivity gives you marginal cost. And this is equal to PO, or price of A by MPA is equal to price of B by MPB is equal to price of C by MPC is equal to price of N by MPN is equal to PO. Based on our equilibrium with one variable input usage, you can say that this is equal to PO. That means price of A by MPA is equal to PO. And if you cross multiply this, price of A is equal to MPA into PO. This is nothing but VMP. Value of marginal product from A is equal to price of A, input A. That is the same conclusion we have derived from optimum quantity with one variable input usage, or equilibrium with one variable input usage. The last point for discussion is returns to scale. In this case, we study what happens to output when the firm increases all inputs in a given proportion. When all inputs are increased by say 10%, if output also increases by 10%, we call it as a constant returns to scale. On the other hand, if increase in output is more than proportional, we say that the returns to scale are increasing. And if increase in output is less than proportional, we call it as decreasing returns to scale. So there are three types of returns to scale: increasing returns, constant returns, and decreasing returns. A doubling of output, doubling of inputs leads to doubling of output, for example, that is called constant returns to scale, or quadrupling of inputs and output also quadruples, that is the case of constant returns to scale. So increasing returns, constant returns, and decreasing returns. Inputs, output. If all inputs are increased in a given proportion, if output is more than proportional, that is called increasing returns, exactly proportional, that is called constant returns, and if it is less than proportional, that is called decreasing returns. Usually, in this diagram, they are shown as separate phases, but while expanding the scale of operations, any firm first passes through a phase of increasing returns and eventually enters into decreasing returns. And in between these two, there will be a temporary phase of constant returns to scale. So the constant returns to scale may be very short or it may be long enough. But Before entering into decreasing returns phase, each firm normally enters into or passes through a phase of constant returns to scale. Then why the firm passes through these phases, or what are the reasons for the emergence of increasing returns or constant or decreasing returns? Increasing returns are purely dimensional reasons. While expanding the scale of operations, a firm initially enjoys the benefits of economies of scale. Economies of scale and increasing returns are the two sides of the same coin. And similarly, diseconomies of scale and decreasing returns are the two sides of the same coin. So, initially a firm enjoys the benefits of increasing returns because of certain advantages like specialization, division of labor, And also you can also explain like purely dimensional reasons. For example, if the diameter of a pipe is doubled, the flow of water through that is more than double. Similarly, take the case of a wooden box that is 1 cubic feet, LBH, length, breadth and height, 1 into 1 into 1. And take another box that is 3 cubic feet, 3 into 3 into 3. The second box, 3 cube feet, that contains 27 times more than the first box. That is purely dimensional reasons. And if you want the specific reasons for the emergence of increasing returns, we all know that equipment is available in given sizes. If you want to expand the scale of operations, you can utilize the existing equipment more efficiently to the fullest extent, and you can also replace with a higher grade or next quality efficient machine that requires less expenditure. For example, take the case of a printing press which can print say 10,000 papers a day or 1 hour. Another machine, it may print say 1 lakh papers per 1 hour or 1 day. That is 10 times more. Output is 10 times more, but certainly the cost or the expenditure required for installing and operating this machine is definitely not 10 times. The output is nearly 10 times, but the expenditure required for using that machine is definitely not 10 times. So that is the advantage of using better quality or higher next size machines. And another one is advantage of specialization and division of labor. Adam Smith has given the famous principle of manufacturing of pins. We know that the entire process of making pin, for example, straightening of the wire, cutting into pieces, making the point and head, if the entire process is done by one worker, then hardly he can make less than 20 pins a day. Instead, if the total task is divided into subtasks, one worker straightens the wire, another worker cuts into pieces, a third worker makes the head, and fourth worker makes the pin. So in this process, if the total work is divided into subtasks and each worker is given one task only, his dexterity, his skill will increase and the output will increase several times compared to the first one. So that is the advantage of division of labor and specialization. By doing the same work repeatedly, one gets dexterity, the skill or dexterity of the worker will increase. So these are the reasons for the emergence of increasing returns. And second, the constant returns to scale. An example for constant returns to scale is Cobb-Douglas production function. So it exhibits constant returns to scale. Mathematicians, the economists use the words of mathematicians to express Cobb-Douglas, a linear function like this. So a linear, it is called linearly homogeneous or homogeneous of the first degree. That means the doubling of inputs leads to doubling of output or existence of constant returns to scale. And the last phase is called decreasing returns to scale. The reasons for the emergence of decreasing returns is mounting problems of coordination and control. If you go on expanding the scale of operations, definitely there will be problems of coordination and control. We all know that by simply expanding the operations, you cannot go on increasing the output. There are certain limitations. There will be problems of coordination, control, and there is another reason also. Though you are changing all other inputs, you are keeping one input as constant, that is the entrepreneur and the services rendered by the entrepreneur. That means you are keeping one input at least as constant. That is the case of law of variable proportions. You are keeping certain inputs as constant and varying other inputs, and eventually the marginal productivity must decline. The application of law of diminishing marginal returns. Okay. This is about returns to scale and the three phases of returns to scale. And here we can also use the technique of budget indifference curve analysis for explaining the returns to scale. We use the isoquant technique here to explain increasing returns, constant returns, and decreasing returns. We know that a movement along an isoquant means a constant output but varying levels of inputs. Input ratio varies, but output remains same. And a movement across an isoquant's output varies and input ratio remains same. For example, you draw two rays OA and OB. Suppose if it intersects at equidistance like this, this is isoquant for 100 units, this is 200 units, 300 units, 400 units like this. And OA, A1, A1, A2, A3 like this. And this is called OB, B1, B2, B3. So if you move along an isoquant like this, either downwards or upwards, output is same, 100 units. But input ratio varies. Here one input ratio, here another input ratio, another input ratio like this. But if you move along an isoquant, output is same and input varies. And if you move across the isoquants, output varies, 100, 200, 300, 400 at least, like this. So this point on the point A on this ray indicates 100 units with a given input ratio. And here output is 200, here it is 300, 400. That means if the successive isoquants intersect the ray OA or OB at equal distances, that indicates that there is constant returns to scale. OA is equal to A1 is equal to A1, A2 is equal to A2, A3. Or OB is equal to B1 is equal to B2, B3, B1, B2 is equal to B2, B3. If the successive isoquants intersect the ray at equal distances, that indicates that doubling of output requires doubling of inputs. Tripling of output requires tripling of input. So that is the case of constant returns to scale. And instead, if the successive isoquants, they come closer, for example, say this is isoquant for 100, you see this is OA, and this is 200, and this is 300, like this, 300, 400. OA, A1, A2, A3. So, doubling of output from 100 to 200, you require less than double the size of inputs. And 200 to 300, again, lesser inputs are required. That's why OA is greater than AA1, AA1 is greater than A1, A2, like this. That is the case of increasing returns. That means doubling of output requires less than twice the size of inputs in case of increasing returns. That means the successive isoquants, they come steadily closer, indicating that lesser and lesser inputs are required for a given increment in output. The opposite case is decreasing returns. Here you represent the graph in this way. If the successive or spaced steadily apart for the, like this. Doubling of output requires more than double the size of inputs, and tripling requires again more inputs are required. This is the case of decreasing returns. So we can use the isoquant map to explain increasing returns, that is by drawing the successive isoquants closer, constant returns by intersecting the line drawn from origin at equidistance, and decreasing returns by spacing the isoquants steadily apart, 100, 200 and 300. And the last point is we have seen that in any forum, while expanding the scale of operations, initially it passes through a phase of increasing returns, then a phase of constant returns, and ultimately decreasing returns. So let us show this from O to A as increasing returns, A to B constant returns, and here B to C decreasing returns. For presenting constant returns, you have to intersect at equidistances, for example like this. You have to see that the distance is equal. And for presenting diminishing returns, you have to see that the distance is farther away, like this. And here the successive, it must come closer, like this. So from O to A, increasing returns, A to B, constant returns, and B to C, decreasing returns. This is all about theory of production or input-output relations. And so far we have seen production with one variable input, production with two variable inputs, and production with all variable inputs. So in the next class we will discuss about the theory of cost. Thank you very much.